Welcome again. This is exercise 2.1 GCE A-level Pure Maths Year 1 on quadratics. We've got 4 questions to answer. Question 1. F of x is equal to 24x minus 43 minus 3x squared. A. Express f of x in the form a brackets x plus b all squared plus c, where a, b, and c are constants. B. Hence, or otherwise, find the exact solutions to f of x is equal to 0. So we have f of x is equal to 24x minus 43 minus 3x squared. I will rewrite the function to make minus 3x squared the first term and 24x the second term and the constant term minus 43 the third term. So if I do that, I'll get minus 3x squared plus 24x minus 43. Then I'll factorize 3 out of the brackets. If I do that, then I will get minus 3 out, brackets, x squared minus 24 over 3x, because minus 3 times minus 24 over 3 will give plus 24x. And then I'll have plus 43 over 3. So if I do that, I'll get this. I can now complete a square within the brackets easily. But before I do that, I need to do a further simplification to give minus 3 brackets x squared minus 8x plus 43 over 3, because this 24 over 3 is 8. Now, we'll go ahead and complete the square inside the bracket. So if I do that, I will get x minus 4, all of that squared, minus 4 squared, that's 16. Then I'll add the 43 over 3. So we get the following. I then multiply minus 3 into the square brackets to get this, because minus 3 times this term here will cancel the 3 here to give minus 43. I then simplify 48 minus 43 to get this. So we have written f of x in this form. So we can say that a is minus 3, b is minus 4, and c is 5. B. We are told to solve f of x equals to 0 to find the exact solutions. But we know that f of x can now be written as minus 3 brackets x minus 4 all squared plus 5. So we equate it to 0 as it's given here, and we're going to get this. Then I'll take this term, the whole of that term, to that side of the equation to make it positive, and so I get this. Then because I want x, I need to take 3 to the other side, and that will divide, and so I'll get x minus 4 all squared is equal to 5 over 3. I can now find the square root of both sides of the equation, and that will give x minus 4 is equal to plus or minus square root of 5 over 3. But I want x, so I'll take 4. I'll take minus 4 to the other side, and I'll get x equals to 4 plus or minus square root of 5 over 3. So these are the two solutions. So the first one is x is equal to 4 plus square root of 5 over 3. But square root of 5 over 3 can be written as square root of 5 over square root of 3. I can now rationalize the denominator of this by multiplying both numerator and denominator by root 3. So I'll have square root of 5 over square root of 3, multiply denominator and numerator by root 3, and that gives square root of 15 divided by 3. So this whole value of x can now be written as 4 over 1 plus square root of 15 over 3. Then I add them. Draw my line here. Lowest common denominator is 3. So 1 goes into 3. 3 times 4 is 12 plus 3 goes into 3, 1. 1 times root 15 is root 15. And so this can be written as that. The other solution is s is equal to 4 minus square root of 5 over 3. Similarly, this can be written as square root of 12 minus square root of 15 over 3. So that's question 1. Question 2. 10x minus 16 minus x squared is equal to p minus brackets x plus q all squared, where p and q are integers. A. Find the value of p and the value of q. Hence, or otherwise, solve the equation 10x minus 16 minus x squared is equal to 0. So we start again by rewriting this equation to make minus x squared the first term, 10x the second term, and the third term will be the constant term minus 16. I can now take minus 1 out of the brackets by factorization, and I get this. So I can now complete a square inside the brackets, and that will be x squared minus 10x plus 16. Complete a square here, I'll get x minus 5, all that squared, minus the 5 squared, that's 25, and then I add the 16. So I'll get this. Now I can expand the brackets by multiplying minus 1 into the bracket to get this. Then 25 minus 16 is 9, so I get this. We need to write it in this form, so we go ahead and do that by writing it this way. So now we can see that it's exactly in this form, where p is 9 and q is minus 5. For b, we are told to solve this equation here, but we know that 10x minus 16 minus x squared can be written as 9 minus x minus 5 all squared. So we can now equate this to 0, and then I can take this term to that side to make it positive, and I'll get that. Find the square root of the right and left hand sides of the equation. We're going to get x minus 5 is equals to plus or minus square root of 9, but square root of 9 is 3. So this becomes x minus 5 is equals to plus or minus 3. Then I'll take minus 5 to the other side, and I'll get x is equals to 5 plus or minus 3. These are two solutions. So the first one is x is equal to 5 plus 3, which is equals to 8. And then the second one is x is equal to 5 minus 3, which is 2. So these are our solution. Question 3. The equation 3x squared plus tx plus 5t is equal to 0, where t is a non-zero constant, has equal roots. Find t. So for a quadratic equation of the form ax squared plus bx plus c equals to 0, the discriminant is defined as b squared minus 4ac. When this quadratic equation has equal roots, then the discriminant b squared minus 4ac will be equals to exactly 0. So for this case, we have a equals to 3, b is equals to t, and c is equals to 5t, the constant term. So we know the discriminant will be equal to 0, where a is 3, b is t, and c is 5t. So the discriminant will be t squared minus 4 times 3 times 5t is equal to 0. Simplify to get t squared minus 60t is equal to 0. We can now factorize this to get t brackets t minus 60 is equal to 0. So when we solve this, one solution will be t equals to 0, but we are told that t is a non-zero constant. So on this occasion, and for this particular question, t cannot be equal to 0. So t minus 60 is equal to 0, and therefore t is equal to 60. And that's our value for t. Question 4. The equation 5 minus x squared all over x plus 3 equals to p, where p is a constant, has a repeated real root. Find the two possible values of p. So this is the equation. We can rewrite it To give this, we did that by taking x plus 3 to the other side to multiply. Now we can rearrange to get s squared plus px plus 3p minus 5 is equal to 0. So now we have got a, the coefficient of s squared to be 1, b, the coefficient of x to be p, and the constant term c is equal to 3p minus 5. And as it was indicated here, the discriminant will be equal to 0 because the equation has a repeated root. And that means p squared minus 4 times 3p minus 5 is equal to 0. Expand the brackets to get p squared minus 12p plus 20 equals to 0. We need to solve for p, and therefore we need to factorize this equation. When we factorize, we are going to get p minus 10 times p minus 2 equals to 0. Then we solve to get p is equal to 10 and p is equal to 2. And these are the two possible values of p for that equation. So this is the end of this session of questions on quadratics. Thank you for watching. I'll see you in the next video.